You now have more than one algebraic method for solving quadratic equations. The strategies are factoring and zero product property, using the quadratic formula, and complete the square. So how can you decide which strategy is best? I'm going to walk you through picking which strategy is best, but I'm not going to solve every single one of these problems. In the homework, you will be solving each one of these problems. So what I look for is I'll pick out all the ones where I think I might be able to use factoring and zero product property. This one is already factored. So all I need to do is ask myself, when can I get each of these factors to equal 0? Another one that I might be able to use factoring on is problem A. I believe I can come up with numbers that multiply to 27 and might add to 12, so I could try factoring on both of those. For complete the square, I need the leading thing in front of the x squared to just be a 1. I can't have a number in front of the x squared. So I might try complete the square for E or for D. Remember that you need to first move everything to one side and get the equation equal to 0. So those red ones are factoring and zero product property. The blue ones are complete the square, choose complete solving for x. And these last two we can solve using quadratic formula. Knowing that, again, you have to move everything over to get the equation equal to 0 first. Quadratic formula. You might get a problem that has a no solution if you end up taking the square root of a negative number. Or you might even end up with one that has only one solution because the square root of 0 is only one option, 0. I picked quadratic formula for B and F because there's bigger numbers. It's hard to factor with big numbers, and it's hard to factor with decimals, and I don't want to complete the square with decimals either. However, quadratic formula would work on all of these problems, but factoring can be faster. The last part of notes for today is something called simplifying square roots. You're going to use this in Algebra 2 quite a bit when you come across quadratic formula problems. This is one of the more difficult ideas. So the square root of 45 is not a whole number, it's a decimal. However, it's hard to estimate what number this is, so what we do is what's called a factor tree. Numbers that multiply to 45 are 9 times 5. And 5 is a prime number, so that stops, but 9 can be broken apart into 3 times 3. So this 9 is special. The square root of 9 is 3, because 3 times 3 is 9. So what we do is we can square root 9, and we get the number 3. That's this paired part at the bottom. But we cannot square root 5, so we keep that inside the square root. And our answer, a simplified square root or simplified radical, is 3 times the square root of 5. It's pronounced 3 root 5. That is the same thing as the square root of 45. And you could check them in a calculator. Type in the square root of 45, get a decimal, type in 3 times square root 5, get a decimal, and they should be the same. For 72, we can start making a factor tree. 72 is 8 times 9. 9 is 3 times 3. 8 is 2 times 4, or 2 times 2. So these ones that are pairs like this are because they came from a number that we can square root. We can square root 4, and we can square root 9. So the number that you see on the pair goes on the outside. There was a 2, and there was a 3. The square root of 4 is 2, or the square root of 9 is 3. And we use multiply, because these are multiplying factors. The number that we couldn't square root that's left over is this extra 2 at the end. And I'll use the highlighter to help you see where the pieces came from. So we got the pair of 2's is this. The group of 3's is this. And the 2 that didn't have a pair or we couldn't square root is left over here. And the way that we write our final answer is the 2 times 3 here, which would be 6 square root 2, is the same thing as the square root of 72. Don't worry if you don't feel like a master of this yet. We'll keep practicing it later on.